It's a recording and a recording. Okay. Hello, future. Okay. So instead of just putting like regular values in here, I can put mouse X, mouse Y, and another mouse X. I can also do some like mathy things. So I could do, you know, mouse X divided by 3 to get some like different values than this mouse X, okay? So what it'll do is it'll just take whatever values are happening with the current mouse X, mouse Y, and it'll mix them in. Does that make sense?
How did you get that box up here?
This is the output of the screen, so you just hit play.
Oh.
That's how you run your sketch. I just didn't put a size in yet.
Okay.
So I'm gonna go ahead and make this 300 by 300. Okay. And so the only downfall of this mouse X, mouse Y is that notice when I'm over here, I don't really get much change. That's because I only have the integers. I have 300 units of space, but with this, I only have the integers of 0 to 255. Does that make sense? So at a certain point, it won't feed in fresh values anymore. There's a way using a map function that you can map different values onto different things. That's in like our processing like 8 workshop. So don't worry about that for right now. But this is just a fun, really quick, simple thing that you can do. You can mix mouse X values with like regular values. This mouse keeps like timing out. Okay, so then, you know, this will only change on the red and the green and not the blue. You know, if you only want your blue values to change, or, you know, or only your red values, you could put mouse X in just red. So you can get really broad with it or really specific with it. Okay, so here's what we're gonna do. Like I said, we're gonna introduce some new concepts. Let me just bring up my example here, if my computer will cooperate. Okay, so we're gonna add one thing here to our size, all right? So blah, blah, blah. See, this is why I hate recording, because all that shit's on the recording. So so in our size, we just have size right now, but there's another parameter that we could put in there. We could put a renderer in there, okay? And so we're gonna be working with some 3D shapes, so we need to just add a keyword for a 3D renderer, okay? We're gonna use our 3D renderer, which is called P3D, processing 3D. It looks like this, uppercase P, A3, uppercase D. It should validate to like a greenish blue color. That's a renderer that comes with processing. Here, I can make this bigger so y'all can see it. I wish I had an easier way to make this bigger and smaller. Is that a little better? Can anybody not see that? Y'all okay? All right. So just add another, so you should have three variables in size, okay? Whatever your size is, and then P3D, all uppercase. Okay, so we have our background, and what we're gonna do now is we are going to draw a sphere, okay? A sphere is a new shape that we're gonna learn. We'll talk about it in a minute. It looks like this. And it only has one parameter that goes into it, okay? And so we can look it up really quick to get those parameters. So I'm just gonna head on over. Y'all don't have to do this, you could just look. All right, so here's sphere, okay? Sphere gets one parameter, all right? It gets the radius of the sphere, okay? So go ahead and just, I don't know, maybe throw like a 40 or something in there for now. Okay, so you should get a sort of sphere-looking thing in the top corner, because just like your ellipse, it's gonna position from the center. Okay, so because this has no other parameters to kind of push around the x and the y, what can I use to push around the x and the y? It starts with a T. Yes. So we'll do translate.
this a separate file from the other one that you?
Yeah, go ahead and do a separate file. Does anybody need another minute to make a separate file or to get set up? Peter, do you need a minute?
Yeah.
Okay. So we're just gonna wait for a couple folks to get set up, but I'll just I'm gonna put the translate here. I'm gonna do that width trick. Width divided by 2, height divided by 2. This is a renderer. So this is our 3D renderer. If we do not, check it out. If I get rid of this, processing will be like, I can't do 3D. So you just have to tell it like, yo, we're working with some 3D stuff. All right, and you can make your sphere as big or as small as you'd like. All right, so if you want to make it bigger, go ahead. All right, Peter, just let me know when you are ready to go. Yours doesn't have them? Yeah. Okay, great. Okay, so now what we're gonna do is let's talk about our translate a bit more. Okay, so because this is 3D, we have 3 dimensions that we can work with, right? Before we were just working with X and Y. Anybody know what the 3rd dimension is? Z, yeah, so we can add a Z in here to our translate. So let's see what happens when I put in like 100. Okay, it's gonna bring it forward more, all right? So less of a Z is gonna push it backwards into space and make it just the size it is. A negative will push it even farther back from your starting point, which is the size that you put it at. Okay, so this will push it, a negative will push it even farther back, and a bigger unit will bring it forward in space. Okay, you do not have to include this if you don't want to for now, but that's just another way of adjusting, so you can actually control that forwards backwards space. So, you know, one thing that we can try is we can try to throw a mouse X in there. And what that will do is it'll bring that shape forwards and backwards into space. Oh, it's gonna get trippier. Yeah. Right? Okay, so everybody's got something that kind of looks like this. Doesn't have to look exactly like mine. Anybody not have this result? Does anybody want me to stop for a minute so you can get caught up? Okay. Okay, so for the time being, I'm gonna take this off. I'm just gonna use translate. I'm gonna put it in the center, and I'm just gonna put 0 here. I might mix this in later. Y'all, I'm just gonna show you all the different ways that you can affect the sphere in different weird ways. So you can mix that back in later. Just for mine, so I can see what I'm doing, I'm gonna throw a 0 in there. Okay, so let's go ahead and let's give it a specific stroke. Okay. So let's give it a color. You can put some mouse X, mouse Y values in there if you want it to change. So you can give it a stroke and a fill color, okay? So I might give mine some random values. Remember this? Nobody remembers random? So this will allow me to say, I'm going to stay at these 2 units of color for the G and the B, but give me, every time the program runs, give me a random red. Okay? So that should affect your, so that would make like a blinky sphere if you do random, or you could just make it a specific color. All right, and then let's also do the fill. So again, you need 3 digits for the fill. You can make it random if you want. You could do some X, Y values. I might do like a 0, 255. And I'll do a random here, but I'll put a limit on it. So before I just had 1 value in there. Now I can put 2. So I'll say anywhere between 200 green and 255 green. All right, so 2 units in your random is going to be start here, end here, so it's a range. 1 unit is from 0 to whatever your number is. All right, so now I should have some little bit of randomizing green color. Let's make this a little larger so you can see it. And some random colors on my stroke. So I got some random greens and some random colors, or random strokes. Make this a little more purple. Cool. Okay, so what we can do now is, remember our rotate function? Anybody remember the rotate function? Yeah? Okay, so remember the rotate function, and the rotate function we put a degree in there, okay? So what we're going to do instead of just rotate, we're going to target the rotate X and the rotate Y. So we're going to target the specific sides of our 3-dimensional space. So I will say rotate X. Oops. And I'm going to put a value that changes in here, okay? Because I want this to just kind of be animating as I go. So for this, you could use mouse X or mouse Y. But before I run it, I'm going to multiply it by a very low number. So let's multiply it by like 0.05. Because if I'm sending, 200 into this rotate every time, it's going to go insane, right? We kind of want it to rotate a little slower. So let's say my mouse is at 100. 100 times 0.05 is how much? Is 5, okay? So this technique here allows me to still use the data from the mouse, but to bring it down a lot lower so that I'm not sending like just insano values into that. Does that make sense to everybody? So if I run this, I should have a shape that now rotates with my mouse. Okay, so then I could do the same exact thing for rotate Y. And maybe I'll use the mouse Y value for this. All right, so now I should have this rotating along 2 axes. All right, so see how it's kind of following both? All right, and you can also do rotate Z. So we got our X, Y, and Z. And you can use either mouse X or mouse Y for that. Okay, so now your sphere should be rotating all over the place. Okay, I'm going to let y'all get caught up here a minute, and then I will show you the last, final, probably most fun detail. Does anyone need any assistance? Okay, let me see. So, oh, actually, it is moving. See, because it's moving like this. So if you put see how it is moving. But if you put Z in there, then this one will, like that point will start rotating around. Tracy, you doing okay? Anybody else need any assistance? Yeah. Oh, try to put the sphere over all of the rotates because anything that, I mean, in terms of it, yeah, it's that like, it'll kind of go, yeah, it's out of logical order. So go ahead and put your sphere underneath the rotates, and I think that should solve it. Okay, so what we're gonna do now is we're gonna call in two other new functions, okay? So let's take a look at, we'll take a look at this sphere, and there's another function that we can use with sphere, okay? Sphere detail, all right? So what this allows you to do, it just gets one integer, all right? And this controls the number of segments per circle resolution, okay? So right now, we have like this sort of max amount of segments, right? We're like creating like a perfect sphere, but we can change the number of segments so that we can actually create different shapes with this. So, Peter, did that fix your issue?
Yeah.
Okay, so we'll put this right above sphere, and we'll just call it, I'm just gonna copy and paste this. Sphere detail is the name of the function, and the lowest that you can have is 3. All right, so let's put a 3 in there, and let's see what it looks like. All right, so you'll get this like gem shape. Okay, so probably very high, but maybe don't put 4,000 in there because it might break your sketch. Okay, so what we're gonna do now though is that same technique where we used, are y'all ready for this? You ready? Okay, all right. Mouse X multiplied by a lower number to get some smaller changes. We're gonna put that same thing in here, okay? So I can use, let's use mouse X, you can use mouse Y, and I'll do like divided by 10. You can do multiply by a small number. Any of these maths that I'm showing you will work, okay? So let's take a look at what happens.
Can we put mouse Y if we want to?
Yeah. Oh, my mouse doesn't work. So it'll change the shape, okay? So the more that you mess with this, right? So yeah, you can do mouse X or mouse Y, whatever you want. But as you notice, like you can put a different, oh, it does not like, oh, here, actually, I'm gonna point this out really quick before I go any further. If you run into an issue like this, okay, so I think it's just important to know like how to debug when the computer's yelling things at you. It's saying the function sphere detail, I don't have a hard time saying that word, expects parameters like sphere detail int, okay? So given what I have here, can anybody guess what this error message is all about? Yeah, exactly, because an integer is a full number. This is not a full number, and I can't pass a float into it. I can't pass a half number into it. I have to pass whole numbers into it. So this technique of the 0.05 is probably not the best to use then. So what you might want to do is just do the divided by, and you can just mess with the number until you get your desired effects.
Could you go back up and just do a float equals that?
Yeah, you could. So that is a way to work around it. However, I still don't know if it would actually work. It would just round up to the next one because this, in terms of sphere detail, you would never have the detail of a sphere that is 30.5. You would only have 30, 31, 32. Does that make sense? But that solution may end up working. Okay? All right, so then, the last thing that we can do is we can have our translate also follow the mouse if you'd like. mouse keeps timing out. Okay, so now you'll have this color changing crystal that kind of follows the mouse around. Okay, pretty cool, right? All right, we're gonna add in one more thing. So I'm gonna let y'all just kind of like mess with this and have some fun for now. If you want to add in another shade, I'll leave this code up here. I just want to see what you can come up with. Okay, so you know, if you want to do another shade, if you want to do, sometimes it's fun to kind of mess with the mouse X and mouse Y. So it's kind of like you're playing chase with the shape. So if you reverse them, it'll kind of do this thing where like doing like the exact opposite of your mouse. Okay, so just play with it, have some fun with it, try out some different stuff, try to get that sphere to have like different values going into it. I'm gonna go grab your worksheets, and then we're gonna just introduce one other new function into here, and then we'll talk about your homework.
Did you stop recording?
Or you can just like take one so you don't have to do stuff. No, no worries. I'm still technically recording. Okay, are we ready for the last little function? Okay, so like I was saying before, we'll go over these explicitly in your notes in a second. But we can use anything that the computer has in terms of like what the computer is doing in real time. We can use in processing. Okay, so we can use a function called seconds. Okay, I'm going to store the function in a variable. Here's what the function looks like. I'll just show you. Okay, so here's all my timing functions that I can use. I can use milliseconds, minutes, hours, day, month, year. These are the functions you're going to use for your abstracted clocks. So I'm going to use the second function. All right, it's just the word second followed by a set of parameters. But I'm going to store it in a variable. So I'm just going to say int, because it's going to be a whole number, right? I'm going to call it s equals second. Close it out. Okay? And then what I'm going to do is I am going to place it inside of my sphere detail. Okay? So I'm going to run it as is, and I want y'all to tell me what's wrong. Okay? So why aren't my sphere sides changing? Can anybody venture a guess? Well, okay, so I have the s, and the s should be whatever second it is at a given time. 0 to 60. Doesn't get a condition. Where's the part of the program that gets live data and updates? Draw. So because this integer, before I was not using variables that were actively changing, right? I was setting it at the beginning and then I was updating it later. But this variable is actively moving and changing. So because it's already actively moving and changing, what part of the program should I put it in? Draw. Does that make sense to everybody? Okay. So I'm going to go ahead and just put this at the beginning of draw, which would be totally fine to do. Whoops. This is what's called the scope of a variable, okay? So the scope of a variable is what is the variable doing and how are you going to use it? When I put it above everything else, that's called global scope, okay? When I put it inside of draw, it's just called the specific scope, okay? This variable I can now only use inside of draw. All right, so now I will replace my seconds variable with the sphere detail. And every second, my sphere, so right now, there we go, see? So every second is gonna add an edge. Okay? We can also replace it with millis, it will be milliseconds. So that one will move a bit faster and might end up breaking my program. Blah! Save. 3D. Okay. It doesn't want to work with millis. I think I might have just broke everything. Shit. Because millis is milliseconds, it moves really fast. So don't do what I just did. Don't mess with millis. All right. You can also do, for instance, minute. But obviously, you know, that will only have a change every minute. Okay. But again, you know, you can do things like minutes divided by, I don't know, 50 or something like that. So you can limit the time a bit more. All right, so this is whatever minute it is divided by 50 right now, and then the next time the minute happens, it'll divide that minute by 50, okay? But second, yeah. Let me just get back to where it was. Yeah, so I can totally do, you know, or even, yeah, second divided by 2, right? So it'll take like whatever second it is, and it will divide it by 2, okay? Okay, so those are just some of the things that you can do. You know, you can also do your math in here. So you could do like seconds times 20, right? So you can like speed things up and slow things down right in your variable as well. Okay? So you can always do weird mathy stuff in multiple places. All right? Okay. Any questions about any of that? It's the sphere size is the radius. So no, because what's happening here, okay, so sorry, I think I know what you're asking. So the seconds will go from 0 to 60, right? And then as soon as it gets to 60, it starts over. So you're right. If you put seconds in here, whatever second it is, whatever given second it is, will be the size of my shape. So right now, we just started over again. So that's why it's tiny. Does that make sense? But let's say you wanted that second to start bigger. So you could do, you know, seconds times 10. So whatever second it is, if it's second 10, it'll be 10 by 10 times 10.
But if you put it in sphere, then it's never ending. It's going to keep going.
Yeah. But as soon as it gets to 60, and then it'll start back over. So it goes 1 second, 2 second, 3 second, 4 second, 5 second, because seconds work in a sequence of 60. So if you looked at a clock, seconds would go from 0 to 60 as soon as it gets to, or 59, and then it would start again at 0. So the same thing is happening here. Same thing with your minutes. So your minutes go from 0 to 60. Your days go from 0 to 365. Your day goes from 0 to 24 hours. Does that make sense? So here's it blowing up again. Okay? All right. So what we're going to do now, go ahead and save whatever progress that you have on this. Please save it to your open processing page. You're going to want to use it for your homework for sure. And does everyone have a worksheet? Does anybody have any extra? Anybody have an extra sheet? It should be just a one-page sheet. Are there any extra anywhere? Or I'll just look at my computer. What y'all think? It's pretty like magic, right? A lot of work for magic. Oh, I want to go here. Okay, so I'm just going to run through this worksheet that's just going to sort of outline a lot of stuff that we've gone over, but also highlight some new functions for making shapes. And then what we're going to do at the end is we're going to do just another little, like maybe 15-minute coding exercise right before the end of class, which will show you how to make those timing functions, make things move and change, okay? And then that's what you're going to do for homework. You're going to create an abstracted clock for homework, okay? So we'll take a look here. Any questions about what we just did at all? Any other questions? There's also, you can use here. There's also a pretty box you can use too, which is linked on your worksheet. Okay. So y'all should have a hard copy of this. There's also a digital copy of this too. I'm gonna write some stuff up here. And so a good thing to do is to get on over to open processing. And as I'm explaining these shapes, we'll take a look at what open processing is telling us. And you'll also take some notes. So I will go ahead and link these so that you have them for your homework. Okay, so let's start with a line, all right? A line works like this. To start with a line, we have to understand a point, okay? Does anybody know the parameters for a point? Or can you guess a parameters for a point? Yeah, so a point is gonna be X and Y. Does anybody know what that grid is called? The grid of processing? I'll buy donuts for everyone if somebody figures it out. So the grid, the processing grid, you know it's all a grid?
Yeah.
Does anybody know what the term for that grid is? Oh, I didn't.
It's not plain.
Thank you.